We're group number 10, and our topic is value stream mapping. So what is it? Value stream mapping is a fundamental lean practice that involves diagramming the material and information flow of a product or service from start to finish. Its purpose is to visualize more than just a single process level and enables you to see the flow of a work across all processes involved in delivering value to the customer. This leads to identifying waste, improving overall time, and improving the process. Value stream mapping involves the creation of current state mapping, which is for helping everyone understand how each step in the process delivers value and identifies areas for improvement, and future state mapping, which represents the target image of how the material and information should flow through the value stream after improvements are made. In essence, the benefits of doing these maps are that it identifies steps as value added, non-value added, and non-value added but necessary. It provides a common language for discussing process, and it forms a basis for implementation planning, serving as a blueprint for improvement.
So how does value stream mapping work? There's four main components to value stream mapping: preparation, create the current state map, create the future state map, and planning and implementation. In figure 2, we have some common VSM symbols that show what the symbol is and say what it represents. First step is preparation. So the first thing you have to do is determine your scope. That is what you're doing, why you're doing it, what your goals are, and even what prompted the operation. Secondly, since you now know your scope, that'll allow you to pick the right team and handpick the right expertise to gather, understand, and act on all the information found. Once you have that information, you can then start building your process family matrix, which is figure 1 here on the side. Across the top, you're going to have all your process steps from beginning to end in order, and down the side, you're going to have all your components, stock, finished goods, or services that your company offers. And then you just put an X in each box that corresponds. So if you use this part in this step, you put an X there. Once you have that done for all parts and process steps, you can identify similarities, looking at process steps that have 100% overlap or 100% overlapping components, and seeing if you can combine them being same worker or related workstations. Then you can evaluate any workstations that have about 80% or above similarities and discuss with your team if you would like to investigate which one, depending on return on investment. So biggest improvements for least amount of dollars or work, greatest reduction in lead time, greatest impact to the customer, or most visible to shareholders. So when creating your current state map, you want to walk the path of the product with your team, moving from the most downstream process to the most upstream. This will allow you to identify any waste and have a chance to talk with operators and supervisors about any misconceptions that you may have on how a process is conducted. Once you have that information, you can then create a sketch similar to the image shown, having all your information on there and using post-it notes to highlight either important information or add new information. Some of the valuable information you want is cycle times, reliability, changeover times, operators, inventory levels, queue times, all that kind of stuff. The last note, your information does not have to be 100% accurate, as you just want to paint a clear picture to develop your lean process map. So when drawing the current state map, you'll start with your supplier and customer in the top opposite corners, add your entry and exit processes, then add in all your other processes from end to beginning, add in all the attributes, put queue time between each process, ensuring it's in the same units, so days, hours, minutes, seconds, map any communication flow that can happen, add some push or pull icons, and any other valuable data. On the bottom, we have a gutter system for production lead time, and on the bottom part, that is value added time. So I'll now pass it off to Alec to talk about future state maps.
So the first question to ask yourself when creating a future state map is, what is the takt time? Takt time is a critical aspect of lean manufacturing and value stream mapping, as it represents the rate at which a product must be completed to meet the customer demand. So if we have 480 minutes of production time available per day, and the demand is 120 units, our takt time is 4 minutes per unit. The next step is to identify any bottlenecks in the current process. These are points in the production process where work tends to accumulate, which slows down the overall flow, similar to a traffic jam. These can be identified by looking for areas with high cycle times or high work in process inventory. Lastly, you want to reduce the inventory/queue, which is essential for improving flow and efficiency. We can use just-in-time production, which aligns production schedules with customer demand, or we can streamline processes and eliminate non-value-added activities. If we find certain steps that could be combined or automated, we can reduce the work in progress inventory. Lastly, for some other improvements to be considered, we have standardizing the work process, which reduces variability and increases predictability, or investing in better tools and equipment to enhance productivity, quality, and reduce line failures. Moving on to planning and implementation, where we examine the plan, do, check, act method, or the PDCA method, which is a continuous and iterative improvement process, which is used to implement changes and ensure their efficacy. The first stage is identifying areas of improvement and developing a detailed plan. This includes setting measurable goals and determining the resources that will be needed to achieve these. Next, we move on to do, which is to implement the plan on a small scale to test for efficacy. And this helps identify any potential issues before any large scale or costly implementation. Next is the check stage, where we use the measurable goals to monitor and evaluate the results of the implementation. And if successful, we move on to the next step, which is act. If the changes are effective, we implement them on a larger or full scale. And if not, we make changes and repeat the cycle.
So how does this help production lines? Well, value stream mapping is a crucial role in helping production lines meet their targets. Firstly, it allows stakeholders to see the assembly line as a whole. Secondly, it visualizes where the key areas of the line are, which allows for an identifiable value of each aspect of the process. And finally, it allows everyone to know their role in the overall process. When everyone understands the value stream, they can work together to achieve the common goal.
Okay, so at this point, we have an understanding of what value stream mapping is. It's a tool for diagramming every step in the process. So let's look at some applications in industry. For the first example, I'm using healthcare, and the simplest application is patient admission. This could either be in the ER or just a simple clinic. VSM could be used to produce a CSM for patient admission, from arrival to processing to either process, or a growing problem in Nova Scotia is patients leaving without being seen by a physician. As you can see, we can create a patient admissions CSM for the emergency unit. And having found the CSM, we can look at a variety of different places to see if the inefficiency is in the simple fact that there's a lack of staff. Hiring and incentive plans can be put in place for either more hours for doctors, nurses, and others, or we just need to hire more. Perhaps if the bottleneck was at registration or somewhere in the paperwork, we can conduct another VSM for the individual request of files, profiles, and patient profiles, and then eventually get to the core of the inefficiency. And aside from patient care, VSM can be applicable in all other aspects of healthcare, like outpatient care, lab testing, pharmaceutical services, surgical pathways, and even more. And outside of health in general, we have a lot of other applications for VSM. In manufacturing, we have production line, logistics and transportation, warehousing, and airport arrivals. In retail, we have inventory and store operations. For construction, any design, any project management. Even in education, admissions or research grant allocation could be used. We chose to emphasize on healthcare because it's often seen as dichotomous to manufacturing and production, showing the vast range of applications. So where can we slot this into our course? Well, obviously, this has to be after the Design 1 project and that material. So this leaves only two places it can be. First is material requirement planning. So some of the pros for having it after materials requirement planning is that MRP provides a structured method for planning and controlling inventory and production schedule. So understanding MRP is to have a solid foundation in management of resource, materials, inventory, which are all crucial for VSM. In addition, MRP also allows us to see a broader picture of how all the materials are used, procured throughout the production system, which can help identify waste opportunities and improve even more effectively when conducting VSM. A con is that sometimes it can be an incredibly heavy focus on inventory management, which is more or less relevant to VSM. So moving on, we can also put it after job shop and flow shops. Obviously, we will see all the benefits of MRP since this is afterwards anyways, but having it after here, since job shop and flow shops focus more on the process, and value stream mapping VSM focuses more on the product, which can fill in the gaps missing by the other. But on the other hand, this can also be the other way around, where VSM can fill in the gaps for learning job shops and flow shops afterwards. And they help detect each other's inefficiencies, so there's less of a difference putting them here after. So some ideas we didn't quite get to discuss is obviously more additional examples from within the industry and how to handle waste when we do identify them. We can also go more in depth with the processes and the matrix of the current state maps and some other aspects of planning and implementation. Thank you.